Short video, we're going to talk about two different ways that infinity comes into play when we're talking about limits. The first is called an infinite limit, specifically an infinite limit at x equals a. If a function value gets infinitely farther from 0 as x gets infinitely closer to a, in other words, the limit of the distance from f of x to 0 as x approaches a is infinite, well, that would look something like this, where we have some function being graphed around a point, around an x value, x equals a, and the function will, as x gets closer to a, get infinitely farther and farther and farther and farther and farther and farther and farther away from 0, which means that, as you've heard this called in the past, there is a vertical asymptote at x equals a. So what we've called a vertical asymptote in the past, we can still call it that, but now we also know that there's a way to write that as a limit. It is important to note, by the way, that generally speaking, we would say in this situation that the limit does not exist. That line in Mean Girls, when at the very end she has that realization trying to win that math competition, she says, if the limit doesn't approach anything, the limit doesn't exist. And you see a graph in the back, this is what they're talking about. If the function is not approaching any one specific value as x approaches a, we usually say the limit does not exist. In some contexts, though, you'll hear it referred to as the limit equaling infinity. That doesn't really make much sense, which is why I don't like to say it, but you might see it sometimes. I did want to quickly point out also that the reason for these absolute value bars is because very frequently a vertical asymptote will be facing in different directions on either side of a. If this is the case, we can certainly say the limit does not exist, whether or not the asymptotes face the same direction. But you've got to be careful. Make sure you don't say that the limit of f of x as x approaches a is equal to infinity if there's a vertical asymptote, because on one side, it's not even approaching infinity, it's approaching negative infinity. So that's why we put the absolute value bars there, so we don't really have to worry about it. Either way, you're also completely fine just saying the limit doesn't exist. The other kind of limit that deals with infinity is not an infinite limit, but a limit at infinity. So instead of the value of the function getting farther and farther from 0, meaning the y value becomes infinitely big, we're going to talk about what happens to the y value when x gets infinitely farther from 0. So there's a limit at infinity if f of x is kept arbitrarily close, meaning gets infinitely closer and closer and closer and closer to some y value as x gets infinitely farther from 0. That y value would be the limit. So we would write this, not that the limit equals infinity, but we're actually now talking about the x value getting infinitely big. So the limit of f of x as x approaches infinity would, the y value would approach some y value L. Meaning, as x gets bigger and bigger and bigger and bigger and bigger, the y value gets closer and closer and closer and closer to L. Well, that has a name also. You know this as a horizontal asymptote. And we will still call them that, horizontal asymptotes. But now we know that there's a way to write a horizontal asymptote with limits as well. So just to recap what we have here, note that when we're talking about a vertical asymptote, we're saying it's the limit as x approaches some real number, but the y value is getting infinitely big, so the limit would equal infinity. For a horizontal asymptote, it's the other way around. The x value is getting infinitely big, but the y value is approaching some specific number. So the limit as x approaches infinity is some actual real number L.